personal views and opinions expressed by our podcast guests are their own and are not legal advice or official statements by their organizations. Hello, my name is Debbie Reynolds. They call me the Data Diva. This is the Data Diva Talks Privacy podcast, where we discuss data privacy issues with industry leaders around the world with information that businesses need to know now. I have a special guest on the show, Jim Barnebee. He is the Chief Executive Officer of Artificial Intelligence Made Easy. Welcome.
Thank you. Glad to be here.
So you and I met, we actually have a mutual friend, Vikas Malhotra. He is the head of Wopley Technologies, and I know you're a member of his board of advisors, but we got together and we collaborate with IEEE with Vikas, and that's how we met. So I think we were on a call one day and you were just brilliant. I thought, oh my God, I have to have him on the show because I feel like he has such a deep knowledge and you're easy to talk to. And I thought that my audience would really love to hear about you and the things that you work on in artificial intelligence. So why don't you start out by giving us an idea of, sort of your career journey in AI and the things that you do at Artificial Intelligence Made Easy?
Of course. So I'll try to be brief about the career history. I have been doing this for like 40 years. So I got my first professional programming job when I was 16. So yeah, I've been doing this for a long time. I started out doing development like most people do. I was a beta tester for Java. I helped create some of the Java specifications. I was on the committees that Sun built in order to continue Java as a growing form. Once Java became super stable, I moved on to architecture work. And I was a UML evangelist at first, because that was a great way to do software engineering. And then I became an ontological evangelist. And ontologies are not a subject most people are familiar with, so let me explain it. An ontology is an overlay of data. So if you have a bunch of heterogeneous data sources around the world, and you want to be able to run queries on those data sources as a data set, there are a couple of different ways to do that. If you can take all of the data and conglomerate it into one location, into a data lake, you can obviously run predictive analytics on it and move forward from there. If, however, you can't move the data, right? You can't move it, you can't change it, it's got to stay in place. What do you do? Well, what you can do is create what they call an ontological overlay, which is essentially where you define the business concepts that are in your data, and then you map those concepts to all the different databases. Then you can use one query structure to query all of the databases in the world at once. So what it does is produce a graph. So it's just set math, right? Set mathematics. It produces a graph, and you are able to query that graph. And then that graph goes out to the data sources and pulls the data back that is relevant to the query that you've presented. So that's how ontologies work. So I was an ontology evangelist for the federal division in Unisys for a while. I became an IBM person to work on Watson. And the reason I joined IBM to work on Watson was because they were utilizing ontologies on the back end. And there's a different set of artificial intelligence areas and capabilities. My specialization is on natural language processing, and data manipulation using natural language processing, which was ontological. So it made sense for me to work on that on the back end. However, they changed the approach of Watson about a year and a half after I joined IBM, and it was a good change. It's not anything bad about what they did. What they did was change from a pipeline that used ontologies to query data across the data set that they wanted to access, and change it to a neural network approach. Well, neural networks are not my specialty. So I went from helping build it to helping sell it. And I joined Global Business Services at IBM with the Watson team doing financial technology. And I spent 5 years or so building artificial intelligence systems that process natural language for Fortune 500 companies. So if you've ever called up a call center and gotten that message that annoyed you that said, oh, press 1 for this and 2 for this and 3 for this, that's not what we built. What we built is a system where you could call up the call center and you could talk to the chatbot. Just talk to it. I want to do this. And it would say, okay, you need to do this, this, and this. And then if it couldn't do it, it would get the right person on the phone to help you move forward. The idea behind that was to make people's jobs easier so they didn't have to completely redo the same steps over and over and over again 100 times a day, such as password resets, right? Now, there are automatic systems that can do password resets. But again, you have to go to the system, you have to log into the system, you have to put the stuff in, you have to run the password reset. There are people in the business environment who will outsource that to a second person. So now you have 2 people involved in one operation just trying to change one password. The average cost of changing a password per person per incident is about $70. If you can reduce that to, say, $5, and you have 10,000 people changing their password a month, you can save considerable money.
Right.
So those are the kind of systems we're building for IBM's financial clients. Now, as part of that, you have to deal with protected data because it's financial transactions. You have to deal with whether or not the users that are accessing the platform want to access it. How do we make it better? How do we make it so that the users want to use it as opposed to typing the number? So that's where we start talking about things like sentiment analysis, which is a big deal right now in AI systems because people feel that when they're speaking to a bot and they're having this discussion with this natural language process, that it analyzing how they feel about the process in real time is somehow invasive. If the system is constructed correctly, what that data should do is let the developers know that this particular interaction is frustrating to a user. That's why they do it, is to determine what the person likes and what the person doesn't like on a holistic basis. So if you have 10,000 users, how do you determine which part of the natural language interface makes those users comfortable and happy and they want to use, and which part really annoys them and they're going to start cursing? That's why they use sentiment analysis. Now, can that, like any other technology, it can be vastly abused. Sort of like PCI data. Yeah, PCI data can be vastly abused. Straight data access, anything like that that is a technology that is progressive can obviously be misused. So for example, wrote a program quite some time ago that you could just go out and it would pull every corporate mention from Twitter in the past month, run it through analysis and tell you how everybody feels about your company. And the people who don't, we can isolate their demographic group and try to improve that. So we have those kinds of systems in place. Now, is that engaging in a privacy issue? For the perspective of the business using it, it's a delta. So if you are not collecting PCI data or PII data, and what you're doing is creating sentiment analysis data or a particular area of the system, then you can use that. That there's no ethical or legal implication to doing that, because what you're essentially saying is this is the part of the system I need to improve. 100 people, 200 people used it, 25 of them didn't like this. I don't know which 25, I don't know what 25, but I know 25 didn't. That's a perfectly legitimate use for sentiment analysis. What is not a good ethical use for sentiment analysis, and this is my opinion, is to determine, and you can do this easily with the same data, is to determine the exact demographic group that is either happy or unhappy with your product, your brand, your messaging, whichever piece, and be able to target. And so you're going after individuals in an individual group. You are identifying individual people and using their data to change your marketing approach or your delivery approach so that you reach a specific demographic. If you're just using demographic data, great. If you're identifying individuals to build that demographic data, it's a failure because you've crossed that line of ethical behavior into targeting specific people for specific reasons. This is very similar to what Facebook does that everyone's so upset about. Whatever you interact with on the platform is recorded and tracked against you personally. So the personalization engines that we use actually direct results based on your personal choices previously. Let's talk about how that can be good and bad. Right?
Yeah.
The good part of it is you have Amazon, and it can tell you, hey, you bought this thing, you can buy this other thing for it for half price. Fantastic. That's something that people want. The downside of that is we now have a system in the background that knows everything you want and everything you've ever done and everybody you've ever talked to within that ecosystem. Going back to ontologies, there are actually methodologies for querying all those ecosystems at once. So if Facebook has some data on you, and Twitter has some data on you, and WhatsApp has some data on you, you can use a social aggregator that is built on an ontological platform to go out and grab specific data about specific people out of all those platforms and collate it. Most people don't realize that that's available. And I can give an example, it's kind of funny. About 10 years ago, I was doing a presentation for the GSA, which is a government group, and they're the ones who buy things, right? So if the Army wants a tank, they tell the GSA, they go pay for it. It's basically the accounting system. We were doing a presentation for them, and I was talking about ontologies and overlays for their financial data and stuff like that. And one of the guys said, so can you show me what this is used for outside of the financial information? I said, sure, give me your email address. He gave me his email address, and live, I pulled up a social aggregator program that was running at the time. It's quite good. And I put in his email address, and I'm live showing this during the meeting. And I said, okay, here's your house, here's your pictures, here's your family. By the way, here's what your daughter's boyfriend wants for Christmas. And half of them wanted to buy it and half were terrified.
Right.
So that kind of, the information exists and it's being collected. The question is it being used appropriately? And how do we safeguard that usage?
Right.
So, yeah, that's why the data becomes important. When you start talking about analytics, right? So there's been a big thing with facial recognition.
Right.
How that works is that you have a system that builds a model. And it's just math. The model is math. Well, we use math to describe events that either are happening or we think are going to happen. And then we can test that mathematical model against the real world. That's great, but how do you build the model? So what you do is you take the system and you give it training data. And you say, take this information. This is the 100,000 things I have for you to look at. Here's 100 that are correct. So X matches Y. And I'm going to give you 200,000 X's. Tell you X matches Y and see how many Y's you get. So, and then you try to make that a little better. So you get, 80, 85% Y out of that match. Here's the problem. If your 200,000 X date training set has just a bunch of white guys, guess what? It's never going to find anything but white guys. I don't care if you put in a green frog.
Right.
The green frog is a white guy because it doesn't know the difference. It hasn't been trained on anything except that one data set.
Right.
So there's a lot of problems with AI in the way that the models are created because of the training data sets. So when people get upset about this model is making bad decisions, yeah, not surprising.
Right.
If you train it with bad data, you get bad models. So garbage in, garbage out. That's our problem. So when people get very concerned and upset about facial recognition algorithms that don't work,
Right.
a bunch of them just don't.
Right.
It's not because the system is bad.
Right.
It's not the math that's your problem.
Right. It's the
data,
input. Right.
it's the data you give the math.
Well, I think too, the problem is, and you're right about this. So the problem is, okay, you have a training set, prove solve your problem or get the data back, the whys, as you say, but then you turn around and try to apply that to a broader group of people, and it was never trained that way. So then now you get people who don't really fit into the box, right? They don't fit into there. So they're kind of an anomaly. And if you're people like me, I'm always not fitting into things. So that to me, that's the problem. That's more of a human problem.
And it's straight up a human problem with the data. Absolutely.
Yeah.
I mean, if I've got an algorithm and I tell it my training set, here's my match, that's a white guy. Anything else in my training set is a green frog. It's going to take anything else and put it in green frog category because it doesn't know any better. It's just math. Right. 1 and 1 equals 2. Okay. And it gives you back 2. If you want to make it so that it actually deals with the population that you're working on, your training data set has to absolutely reflect that population.
That's right.
Because if you don't, it can never figure out the right answer.
Exactly.
People think AI is smart. AI is incredibly stupid.
Well, it's doing what you tell it to do, right?
It's doing what you tell it to do. People ask me about my job, and I tell them I try to make computers less stupid. But they are. It's a math engine. Right?
Right.
If you get to the fundamental level of computer science, it's a math engine. So it's just equations, it's just math, it's predictive analytics, which is curve fitting stuff. It's just math. If we feed really bad data into our math, we get a really bad model out the back end, or you end up with a flat earth. It doesn't work.
Right. And then too, one thing that I'm concerned about is the way people use statistics to try to tell the story about humans, right? So let's say you have an algorithm that's saying, okay, let's decide who's guilty or innocent of a crime. So we think 90% of people are innocent, but who are these 10%? And how did you decide, how did the algorithm decide those 10%? It's not numbers, those are people, right? So if something bad happens to you, statistics don't mean anything.
You're absolutely right. So this goes back to how do you design the system that finds the X equals Y? So if you're talking about an image recognition algorithm, they take a whole bunch of data and give it a match and tell it to just go learn. Just trowel through the data, keep going it over and over. And when they get the results, they say, this was right, this was wrong, and they send it back and run another cycle, which is great. But again, if you're doing something like these individuals are guilty, these individuals are innocent, facial rec isn't going to do that. And the fact that they try to apply it to that problem, it's taking a hammer and trying to, loosen up a screw. It's not going to work. Wrong approach. What you need to do for that kind of situation where you're trying to solve a holistic issue rather than a precise one is to create a larger structure of the data that you can actually analyze. So this is a great place where ontologies come in.
Right.
So if I go into an ontology and I say, here are the 25 characteristics that we're going to look for to determine guilt, right? Innocence and guilt is what we're talking about. So these are our 25 characteristics. And then I put in the data set that runs on top of 10,000 people. And it's got to be a cross section of every court case that's been run in the past 40 years, right? You need that kind of data. Who's been innocent, who's been guilty, and what are all their attributes? Not just, height and weight and race, but where do they live? What are their socioeconomic conditions? What is the rates of crime in their area? What are the extenuating factors? Like, is this person a minor, or do they have something else going on? We have to take all of that data into consideration in order to make a cohesive decision holistically. So you can put all that information in ontology. Then you could query it to find the people who matched all those conditions. Then you can do a statistical analysis on that, because then you're actually comparing apples to apples. The biggest problem we have with AI in training data is that people compare apples to oranges, and it doesn't work.
Or like I say, apples to grapes.
It just doesn't work. And it's not the fault of the math, because it's just math.
Yeah.
Fault of people who don't spend the time to properly curate the data and align it so that they get the right answers out of the models. Half of that is people don't know what data they have, or how to cleanse it, or how to align it. And if you get somebody in who's just, I'm going to build a model on whatever data I've got, that's what you get, is a model on whatever data you have. If you have a group that can go in, and we used to do this when I worked for these other guys for IBM, we'd go in and look at the data set and actually analyze it and say, does this data work? Does it make sense? Is it correct? Is it organized in a way that we can get the right answer as opposed to just any answer? That's a non-trivial process. That takes time.
Absolutely.
And it's very complex. And the more data sets you have, and the bigger they are, and the more distributed they are, the harder that is to do. So one of the ways to fix that is to create a big overlay of all the data and then pull the specific things you want out of that giant data set, with as many conditions as you want to impose. If you can't do something like that and say, this is good data that I'm trying to use for my training set, this is good data that I know matches, and then run that through the algorithm. If you can't do that and start with good data, you're never going to get good results. And that's where we see a lot of AI projects fall. They don't have good requirements coming out the front end. They don't have a good understanding of what their data is that they're feeding into it. And because of those two issues, they're never going to get good data out the other side.
Yeah, tell me about, I feel like people, maybe from movies, they think AI is magical, right? It can do all these crazy things. And I don't know about you, I'm like screaming at the screen, like, oh my God, that doesn't actually happen. But I think when you're trying to educate people, you have to sort of talk them down from this magical theory about artificial intelligence and what it actually does. Tell me a little bit about that process for you.
Sure. So the number of times I've told people that there is no magic bullet, there is no magic, it's just math. It's a lot of really cool math, and it makes it look really good on the backside so people can use it easily and understand it, work with it. At the core, it's just math. So if you look at any area of artificial intelligence, there is no Terminator. There's no general artificial intelligence. When you talk to a bot, it's not thinking. It's running math to try to come up with an answer that answers the question you asked. That's exactly what it's. So how do we do that? Well, we have different areas of artificial intelligence, and within each of those areas, we have specializations. So for example, if we take AI holistically and we look at it as all the different pieces we can do, we have stuff like natural language processing, which is involved with text to speech and speech to text and analysis of speech and putting together speech. It's essentially natural language. How do we talk to a machine, have it understand what we're saying, and talk back to us in a way we can understand? So that's what natural language processing is and does. That's what my company does, is create those kind of interfaces onto anything else. All right, so any other system you have on the back end, we create this nice way you can talk to it, it'll talk back, and it can actually understand what you're asking. Now, there's a trick to that, in that it's just math. So we can't ask it to understand anything that you say because we'd be there forever. So what we do is say, okay, for your domain, right, you are Fred's Bank. Okay, Fred's Bank. Let's go look at all the Fred's Bank questions that you get, break them down, figure out how to answer them by querying the backend systems and how you want to hear the results back. Then we can build that interface. But the reason you can't just go buy an AI and turn it on and it's magic and it works is because you haven't taught it anything. So the one I used to use, and I'm calling out IBM a lot on this because they're good at it. We would go in and we say things like, okay, we want to buy it. We want to just use it. Okay, well, we have one that won Jeopardy. Would you like us to come in and win Jeopardy for you? That's no problem. We have that. We can go win Jeopardy all day long. What I can't do is set up Fred's Bank by telling it to go play Jeopardy.
Right.
So we have to take the thing that learned how to play Jeopardy and teach it how to play Fred's Bank. That's the natural language area of artificial intelligence. Then we have things like expert systems, which are basically rule-based algorithms that have a bunch of flexibility that let you do specific things for knowledge capture and dissemination is mostly what expert systems are used for. For example, if I have 100 people in my organization and we're all architects and we need to store all these plans, how they operate on the plans, how they store them, what they get out of them, those are all knowledge that individuals have in the company. Well, if that person leaves, I don't want to lose that knowledge. I can codify that knowledge into an expert system where people can go query for that and say, hey, I need to solve this very detailed technical problem in my particular area, like I'm building a plane and I need to know how this part goes in. And the manual says this, but the guy who's been doing it for 20 years says, no, 20 degrees off, put it in. Which one do you want? I want the guy with 20 years experience telling my people, do the manual, then turn it 20 degrees. That's the kind of thing we can capture with an expert system. So when you ask the question, you get back the answer that contains all that information. Does that make sense?
Absolutely. Also, one thing that I think is interesting with this is that this kind of goes to the magical thinking. You know, in order for you to use a system like this, you have to anticipate what you think the questions would be, right? The things that people are trying to answer. And then I think some people, they're asking questions that the model was never trained to answer, right? And sometimes, to me, those models, just like you go to Google and if you search for something, it says, you have 1 million results, which is not true, right? Like no one would use Google if nothing came up. If they say, oh, I don't, I can't understand your query. So in some ways, I feel like some of these artificial intelligence systems are built to try to make people get a result, even though it's not a very good result, just to make it seem like it's working.
And if you look at the search engine algorithms, yeah, they're going to get the nearest next match from their data set. If they can match one word, they'll pull that up. If they can match 5 words, they'll pull that up. And they'll put it in order of precedence. We match 5 words, 4 words, 3 words, whatever. That's keyword search. There's also cognitive search. And Google's gotten pretty good at that. That's where if you type in a phrase that says, how much do alligators eat? It can go pull up information from a zoological database about alligators because it understands that you're asking about alligators, but you're asking a specific question. Now, if you just put in the words alligator feed, you're going to get a bunch of pictures of alligators eating things, not what to feed. So that's the difference between a keyword search and a cognitive search. A cognitive search tries to take the context of the data into account when making the query, i.e., what does this mean? Right? If I put these 10 words together, does it mean the same thing as if I put these 3 words apart? So there's that aspect of it for generic search engines. They've got some amazing stuff. They do a great job. It's not a trivial problem, particularly with the internet, because indexing and understanding the context of that much data that changes constantly is an incredibly difficult problem, which is why they dedicate giant buildings of servers to it.
So tell me what's happening in the news right now or in the world right now related to AI that concerns you most? Like, what are the news stories you heard about that just made you like, oh my God, I can't believe this? Or, what was concerning to you right now?
What really concerns me most with AI, there's two things that concern me most with AI implementations. The first is that the general public isn't clear on what different types of AI are and what they do. There are many people who still believe or think from the movies, oh, it's Terminator and it's going to take over and kill everybody, or it's going to do all my laundry for me. It's going to be the AI that runs the robot that runs my house. Neither of those things, right? Maybe eventually we'll get a robot that works, and they're coming up with those and they're getting better, but they're still just doing what you tell them to do. There is no AI system anywhere in the world that thinks for itself. Doesn't happen. If we ever get that, fantastic. I'd love to see it. People say, do you want that's what they call general artificial intelligence, as opposed to specific. People say, would you like to have general artificial intelligence? Yeah, we don't have much of the other kind. It can't hurt, right? But the question there is, what happens after? So people call the idea that an AI becomes self-aware the singularity, because we have no idea how that will affect everything.
Right.
Not something we have to worry about. You got 10, 20 years before anybody starts getting close to that. Some of the quantum stuff is being starting to be looked at in that regard. But it's going to take decades for us to hit the singularity. Until then, what we have are specific math, right? Specific types of artificial intelligence algorithms that work on specific type of problems. So if your problem, as I mentioned before, is trying to determine what somebody says and what you should say back, well, that's natural language processing. Expert systems are stuff like teach my system about medical clinical stuff. And then the doctors can go back and pull that information easily. All right. So we have a bunch of doctors put some information in, and then another doctor can go look that information up. Medical is a great area for that because you've got a vast amount of data that comes at medical professionals constantly. There's no way they can keep up with it. They're not going to read all that. Can't be done.
Right.
Even if they spent 24 hours a day, they're not going to be able to get all that information brought in. If we use an expert system, as that data comes in, we codify it, classify it, stick it in a data set, and then use an expert system to allow us to query that data set. Then when the doctor comes in, they can say, okay, I have this problem, and they can put it in and they can see from the data the last 15 people who've had that problem and what the most recent research is regarding it. So that's kind of an area for an expert system, stuff like taxes, stocks, flight tracking, things that people do that we want to enable others to share that knowledge. So that's more the expert system area. We have fuzzy logic. Your self-driving car. Great example. It's got to all the time figure out where it is, where everything else is, how to get around it, what to do. So it's not doing, if I see a car, stop. It's doing, if I see a car in these conditions and these conditions and these conditions, and these are the different choices I want to make, right? It's taking all that into account to make a fuzzy decision. And fuzzy decision, we're talking about probabilistic. So not you can't predict the outcome because it's a probabilistic problem.
Exactly.
We have things like robotics. Want that robot running around your house? Hey, we can do that. Driverless, the actual driving of the car, manufacturing stuff, right? So you have the robot that puts together the Toyota. That's an entire area of artificial intelligence. Mm-hmm. That's kind of interesting. So if you have a grid and you have a robot that can do neural network visual recognition and expert systems and fuzzy logic, and you put it into a robot and you give it a pegboard and you show it once how to put the pegs in the board, it can do that forever and never make a mistake. You teach it, again, it's just an AI system, so you teach it what you want and it goes and does it quickly, repetitively, forever. What it doesn't do is make independent decisions about whether or not to change it. It just does what you're telling it to do.
Right.
Math, well, the math enables you to make that fuzzy and say, well, if these things happen, do this. If these things happen, do this. And if these things happen, do some other things. You can do that. But again, it's just saying, well, here's what happened. What's my probability? It's 20 of this, 30 of this, 40 of this. Okay, I want to make that decision. It's not actually making an independent thought-based decision. They can't do that.
Right.
Neural networks are another area of AI. So I was talking about facial recognition, noise recognition, pathfinding. So neural networks are great for stuff like how do I solve the traveling salesman problem? And for those who aren't familiar on the call, traveling salesman is a fairly well-known mathematical problem where you have 50 cities and you have a person going to each city to sell X. What's the most efficient route between those cities? Right, and how you calculate that. That's a fairly well-known problem. It gets interesting when you've got moving targets. So you've got a person who's delivering food and they have 4 deliveries on their plate. Well, then one drops off, one comes on. You've changed your target profile. You've changed where they have to go. We have traffic jam. We have to route them around it. So we changed how they have to go. So you have to monitor all the conditions around that path and determine how to restructure and route that path in real time. That's a very non-trivial problem. That's difficult. So it's sort of an extension of the traveling salesman problem that we keep running into, and we can use neural networks to find the best path through those, if that makes sense. It's the same tech we use on like facial recognition. You give it a huge bunch of data, you tell it what the right answer is, you see what it comes up with, you optimize. And all AI basically works that way. And there's a lot of precision here, and I'm sure I'm going to get pushback from AI people going, no, this, and that's fine. So the point I'm trying to make is AI is math, it's algorithms, it doesn't think for itself, there is no terminator. You just feed it data, tell it what you want, and see what comes out the other end, and then go back and optimize it until you're getting a result that's mostly correct. You are never, and this, and again, I'm probably going to have AI people yell at me, but I have never seen a system that was 100% accurate in AI, ever. I don't even think it's possible. Now, there's a lot of fault-tolerant systems and a lot of good systems that function, like your driverless cars.
Right.
But those algorithms have internal mistakes. Things go wrong. They just have other stuff on top of it that says, if this goes wrong, go over there and do that.
Right.
So there's never 100%. So if you're talking about language, right, you get 80%. Right? If you get 85% in a language model, it's considered really good. And 50% flows through to the we don't know what to do with it. Right?
Yeah.
Obviously, expert systems, those are a little simpler because you're recording knowledge and sending knowledge back through the system. Right? So whether or not you're using that knowledge to track flights and help airport personnel, or you're using it to help financial people with stock trading or doctors, right? That's your knowledge base that's being queried. You're still going to have issues, right? And I've seen this with like medical programs where it's mostly right, but occasionally it grabs an article or a piece of data that's not related to the question you asked. And in a medical situation, that can be serious, right? That's why there's no automatic doctors.
Right.
That's the problem we can't fix with an automatic doctor. You can have a doc in a box, which gives you advice and information, but it should not be making decisions.
Right.
So when we talk about autonomous systems, systems that are working by themselves, you're still going to have that 85-15 rule. Those 15% is where the autonomous system has to go back and run its error systems. Oh, that doesn't fit the curve that I normally have. What do I do with it? Okay, I have to run through my fault tolerance, figure out what's going on, and then fix it. So that's why you see things like automatic cars that 99.9999% of the time don't have an issue. And occasionally somebody, my personal favorite was they took an automatic car and they painted a circle around it. Good move. It was told not to go across that line. The line was all the way around it.
Right.
It just stopped. So it just stopped and went, okay, I'm where I'm supposed to be. I'm doing the right thing. I'm sitting here. And it would refuse to move because the rule said you can't cross that line. Okay.
Right.
So they had to kind of figure out a way around that because, yeah, that was funny. Yeah, an automatic parking spot, draw a circle. There you go.
Right.
So, and that's way out in that 15%, right?
Right.
How many people who have an automatic car are going to make it drive into a circle of white line where it can't go across?
Right.
Probably not going to happen, but it could.
Absolutely.
So that's in that error category. Yeah, what do we do now?
Absolutely.
So the thing I would really want to convey to people about artificial intelligence is it's not bad, it's not dangerous, it's just a tool. It's a chunk of math. We use it to make things faster, better, easier. Sometimes people use it in other ways that's not as productive for the society, shall we say.
Yeah, I don't know. I like to say people think of AI as a teddy bear, and I think it's a grizzly bear. So I think you need to know what it's doing, why it's doing it, and then you can't like abdicate your human judgment to machine, right? You're telling it what to do. It should be telling you what to do.
Exactly. AI systems are fantastic helpers.
Helpers, absolutely.
That's
not leaders.
No. I had a professor who used to say to me that if a human being has to do it more than once, get a system to do it because you're wasting brain power. Human beings should use AI systems to accomplish their tasks faster, easier, and better. They should not be using them to take advantage of other people,
right,
or to do other things of that nature. But the system itself is simply a useful chunk of math modeling.
Exactly.
It's a bear. You can train it to work in the circus and juggle balls, or you can train it to go eat somebody.
That's right.
And it's a bear. You just train it and it does what it does.
Exactly.
So, we have to just make sure that when we use these systems, we use them well, we use them correctly, and most important, that people know what to expect out of them. I keep saying it, but one of the main reasons any AI project fails in any industry at any time is poor requirements.
Yes.
If they don't know what to expect on the other end of that project, and you don't have methodologies to test and make sure that the users are getting what they want as you go through it, you're going to have issues when you get to the other end, because it's not going to meet the need that was originally submitted for the project. So,
right.
Take off my developer hat for a second, put on my manager hat for a second. We need to know what the outcome is that the individuals want. If they want to be able to ask a question and get queries from this BI system, fantastic. Right? Then we know what we expect. We expect those queries to run this way at the end. If you have somebody who comes in and says, I want some AI. Okay, great. What exactly do you want it to do? Make things better. Okay. Which exact thing do you want to make better in what way? If you can answer the question of what you want to make better, what you want to do to it to make it better, and how you measure the result, you can have a successful AI project.
Yeah. I think too, I was incensed. There was a situation where someone in a medical situation, they couldn't figure out, I guess AI was looking at x-rays, and the x-rays, they could tell from the x-rays like the race of the person. And some of the doctors that were using it, they said, well, we don't know why it did that or whatever. And it's like, what? It's like, what do you mean you don't know why? It's like, you should be very clear on what the AI is doing and what the result is. And if the result is not what you expect, you need to go back and look at it.
Well, you definitely need to go back and look at it. But what you're talking about there is ancillary data.
Mm-hmm.
If they put in all the conditions for here are the x-rays and here's the matching set, right? And then go run it till the neural net actually understands that, oh, that's what I'm supposed to look for. If the data that is matched with what they're supposed to look for in the x-rays, and in that x-ray data, they say the race is actually included in that data, then the system can make an inference, and it's
right.
just probability, right? It's just running numbers. And the inference it's going to make is individuals who are listed as this race have this more often than individuals as this race have this. You want to fix that? Take race out of it.
That's right.
Move race from the data set. And then it won't find it anymore because it's not there.
Right.
And so that's the kind of and they didn't know. I'm sure they didn't know ahead of time that they were even feeding race into that characteristic set. Because they have 100, 200, 300 different characteristics that they're feeding into that program to tell it how to look at those x-rays. If just one of those sets of characteristic happen to include race from the data they pulled, then it'll show up on the other end. It goes back to that data cleansing I talked about.
Right.
You got to make sure your data's good, it makes sense, and it does only what you want it to do before you feed it to the AI. Otherwise, you get results on the back end. You're like, I don't know where that came from.
Right.
Because you put data in on it.
Exactly. So if it were a world according to you, Jim, and we did everything you said, what would be your wish for either AI, privacy, data stuff in the future? What are your thoughts?
Well, privacy is a whole different subject. I think in the privacy arena, what we need is for individuals to be able to control their own data. So I can decide whether or not the bank wants to use my data in their algorithm to determine pricing on savings accounts, right? I get to decide if my personal data goes into that data set. That would be the first thing. And there's some people working on things like that right now with sovereign identity and digital identity. So if we can get something like that where individuals can actually control the usage of their data, that's step one. Step two is to look at the algorithms, right? So how many of those are producing data that wasn't expected, right? And why? And that goes back to checking out the data, making sure it's cleansed. You know, you and I have talked about specifically image recognition and it all showing up as white guys or green frogs, right? So that's a problem with the data set. And if we don't put good data in, we get garbage out the other side. What I would love to see is AI helping everyone. I would love to see it easy and simple so you could just walk into a room and tell the room what you wanted and it would go figure it out and bring it back. I want to see Star Trek computers. I want to see where you can just talk to the thing and it goes out and figures everything you want out and brings it back. And if it has to use neural networks or fuzzy recognitions or make a robot, run a screen up and down, whatever it has to do to accomplish what you want. One of the biggest issues I think we have with computer science as a whole is that most people can't use it.
Right.
Most people are not going to go in and create a data model. Most people are not going to go in and build cloud infrastructure, right? Just examples. You have to go hire an IT person to go do that. I've been trying to work myself out of a job for decades. I want people to be able to just work with machines flawlessly, seamlessly, with no effort. It shouldn't be hard for people to get assistance from an artificial intelligence. It should be easy. Kind of the name,
right.
Easy, right? So that's what we try to do, is just make it easy. And what I would love to see is every computer, every system, everywhere in the world, so easy to use that a 4-year-old can walk in and use it without ever having touched a machine. That's what I want.
That's amazing. I love that. Oh, wow. Well, thank you so much. This is a very instructive episode. I love it. I'm so excited about being able to collaborate with you on IEEE and some of the interesting things that we're working on. And man, this is amazing. I love this episode. Thank you so much, Jim, for being on the episode. This was great. I think I've never heard anyone explain AI in the way that you did it. You do it in such a simple way that anybody can understand. So I think you live up to the name of your company, AI Made Easy, because you definitely made it much simpler for me and other people to understand.
Well, that is the goal. To make it easy for everyone to use this and get the benefits out of these types of systems.
Excellent. Well, I'm sure we'll be in touch soon.
I say, as William Gibson used to say, the future's arrived. It's just not very evenly distributed.
That's very apt. That's a very apt analogy. We need to get it more evenly distributed for sure.
Yeah, if we could take all of the magnificent things we can do now and put them in everyone's hands in an easy way to do things, we could build a utopian society. We have the technology, we have the ability, we have the resources. People can't get access to them and use them.
Right.
That's what we have to fix.
I agree. Wonderful. Thank you so much. I really appreciate it. And I look forward to chatting with you soon.
Me too. Thank you very much for the opportunity.
Thank you.